Hi everyone, and welcome to our video on the introduction to expected value. So expected value is all about these probability distributions. So in our last video we found them. Okay, so in this second one took a little bit of time, but we found them, and then we use them to help us with these expected value problems. The expected value is the long run average. Okay, so like in the long run, so that means if you do an experiment millions and millions of times, that's what this expected value is trying to find, but without actually doing it millions and millions of times. Okay, so like the expected value, this would be, is very important for like casinos and gambling. So they know, for instance, like the expected value, say somebody's playing roulette, which is a game where you spin a wheel and a ball lands on a number. If somebody plays that and wins 5 times in a row, you know, the casino, even if they're betting a lot of money, say they're betting millions of dollars, the casino is okay with that. They say, all right, that's okay. Because they know in the long run, eventually the person is going to lose. So if they keep betting, eventually they will lose because, well, the probabilities are against them. Okay, so that's kind of one of the main things expected. It also is like is used for lotteries. So like if you're buying lottery tickets, you know, sometimes you win, sometimes you lose. Actually, probably majority of the times you lose, right? Unless you're super lucky. I mean, that would be awesome. But the expected value of a lottery ticket is usually like a negative value. So it's like each time you buy a lottery ticket, you lose money. Okay, so anyway, so that's what the expected value means. In math, this is how we find it. In words, it's taking your x value and multiplying it by your probability value and then adding them all up. Okay, so for instance, let's see it. So in this example, find the expected value for the random variable. So the way I think of it is I just use, so this table is key. I just group these vertically like that. And our expected value, and you could just write e, here they did e of x, I'm going to do just e for this problem, is to take your x value, 0, for the first one, and times it by the probability value, 0.1, and then in each of these, just make sure to put a little plus sign in between. So notice I'm multiplying these vertically, and then I will add them afterwards. So then 10 would times 0.25, and then plus 20 would times 0.45, and then plus 30 would times the 0.20. Okay, and then from here is where we could just use a calculator. I'm going to go ahead and use Desmos. Okay, so let me pull that up. So here's Desmos. I've used it in other videos. If you've watched my other videos, I just like to use the scientific calculator. Okay, so I'm going to type all these in. Okay, so right there. Okay, so, and this first one, actually, let's go ahead and write e equals 0 times anything will be 0. So I can just write that. I'll use a placeholder. 10 times this, well, that one's not too bad. That is 2.5. Actually, maybe we could do these without it. If we were to multiply this one, it would be 9. And then multiplying this one, it would be 6. Okay, so that one, yeah, I could do that. Okay, so if you need the calculator, use it. No shame in that. Maybe verify my results and let me know if I accidentally did this with poor arithmetic. Okay, but I think all of them are right. Okay, so there's our sum. When then we officially add it, we would get 17.5. Okay, so the expected value for this random variable is 17.5. All right, we'll interpret the actual answer in a little bit for a better problem. So this is just random right now. Okay, so in this one, find the expected value. So here we have the graph. It's actually the same graph from the previous video. So we could scroll and copy, or I mean, this one isn't that bad at all. We could write it. So our x values are the 1, 2, 3, 4, 5. And then our probabilities are 0.1, 0.2, 0.4, 0.2, and 0.1. Okay, and so this is me sketching it if they didn't make it, and you could make it nicer if you want, like you could put these bars in. So it's completely up to you after we've got the main parts of it done. Okay, but now I'm going to take my verticals. So I think it's best if we always kind of do x and then, so I think it's always best like this. And then from there you fill in this information. Okay, so however, some of these problems, they might go like that and fill in that information. Either way, we would still just think take your x value and multiply it by your probability value, and then add those as you go. Okay, so the expected value, this time let's go ahead and use e of x the way that they have it in the formula. But again, I usually just do e equals, and then we would have 1 times the 0.1, and then plus, let's go and circle those now, plus 2 times the 0.2, plus 3 times the 0.4, plus 4 times the 0.2, and then plus 5 times the 0.1. And then from here, we have e of x equals, this one is 0.1, this one is 0.4, the next one is 1.2, this next one is 0.8, and then the last one is 0.5. Okay, so that was nice enough. Again, if you need the calculator, go ahead and jump to it. It's perfectly fine. And then from here, I am going to add those up to finish it off. Okay, so I pushed the wrong button on my pen. It does simplify to become just 3. Okay, so that's our answer for this one. Okay, so let's see one more example in this page or in this video. So here we've got a spin game. So what is the expected value of the spin game below? So they didn't show the little spinner. So it's like Twister, like where you flick this thing and it lands on a number. Okay, so this time around we need to find those probabilities. They're making it a little harder, but I'm going to set up my horizontal table. Now the x values are the 2. And you could put them in any order. I am just going to do smallest to largest. So 2, 4, and 16. And then I want to find those probabilities that match. Well, when it comes to this board, it looks like it's cut into a half here and then cut into another half. So, I mean, if half the board is 4, that would be the probability that it lands on 4. And then each of these is a quarter of the circle. So that means these would be 1/4 and 1/4. And you can convert these to decimals too. I'm just going to keep them as fractions though for this problem. Okay, so the expected value, let's use e again, is going and taking these vertically and multiplying them. So 2 times 1/4 plus 4 times 1/2 plus 16 times 1/4. And so when we multiply it, this does become 0.5 plus 2 plus 4. And so our expected value is 6.5. Okay, this is the one I want to try to break down in words since it has, because these first two are just abstract. We don't know what they were referring to. At least this time we see it's referring to a spin game. So this value, the 6.5, this is like the average value. We'll put it in quotes. Average value of a spin. Okay, so notice we can't actually get 6.5 on a single spin, but this is the average value of a spin. So what this means is if we were to play this game like 1,000,000 times, so playing this game, let me even put that. So if we play millions of times, okay, so that would be the long run. So if we play this game millions of times, that would take years to play this game millions of times. If we play this game millions of times and recorded all of the results for each spin, so say we landed on 4, and then 4, and then 2, and then 4, and then 16, so forth. If we add up all those results and then divide by the number of times we play it, we should get 6.5. Okay, so if we play the game millions of times, saying our average should equal 6.5. So, and our average would be the sum of all of the times that we played it divided by the number of times that we played it. Okay, so if we played it millions of times, that's what would go in the denominator. The sum should go in the numerator, which again would take a very long time to actually find. But when we divide the two, I mean, that's how you find the average. It should be right around 6.5. Okay, so that's what this means. Okay, anyway, so we'll do some other. Let's pause this one. we'll go into where it's truly made in gambling scenarios. Okay, so these are random ones. All right, so let's see where it's more useful. Okay, so anyway, but this is the strategy to do it. So that as long as you get your table, so the main thing is get the table, multiply the x and the probability, and add them as you go. Okay, so thanks for watching. We've got one more coming, but if you do have questions, let me know, and I'll see you again soon.